A and B, right? And I store A in my first storage, right? And get my B, add them up, squared it, that is my top number. In this case, my scary DF is 74. Once you get your DF, be sure to run it down, not run it up. My scary DF is 74. I go to page 157. And my alpha is, where's my alpha? This is my alpha, 0.025. 74.025. I have 1.993. 1.993. 1.993. All right. Step 3. What is my decision rule? Since we only have one tail task, then this is the one that we should focus on. Reject HO if my T stack is less than negative 1.993. This is my decision rule. If my test statistic is less than my T crit, this is my T crit. Or I can say, if the p-value of my test statistic is less than T alpha, right? That is another way to identify if this test works, right? We can compare T-stat with T-crit, or we can compare the p-value of my test statistic and the alpha. In this case, we only compare the T-stat with the T-crit. Step 4, what is my test statistic? What is my test statistic? If you have the packet, let's go to page 190. Yeah. As you can see, we have over 30 formulas on your final exam. Yeah. It's a lot. We have over 30 formulas on the final exam. So try to play around with them, practice as much as possible before your final exam. Right. So what is the formula for my test statistic if we have a scary DF? My T stat equals. What is my top?
S1 squared.
X bar 1 minus X bar 2 minus hypothesis value, right? Which is 0 in this case. And over big square root.
S1 squared.
S1 squared over N1 plus SQ squared over N2. Right? All right, so in this case, what is my 1 and what is my 2? Or I am asking, what is the order?
Boston minus Buffalo.
Boston minus Buffalo. All right, so if that is the order, what is my X1?
Boston.
Boston. So the X bar for Boston minus the X bar for Buffalo. Get the difference between these two guys, subtract by 0, over S1 squared divided by N1 S2 squared by n divided by n2. What is my S1? My S1 is the standard deviation for Boston, right? Which is right here, 7.4. 7.4 squared divided by 32, which is my N1. 8.9, which is my S2, squared it, divided by 59, which is my N2. We've got negative 3.7, which is my top number. What is my denominator? 7.4 squared it divided by 32 square 2. 8.9 squared it divided by 59 square 3. Now recall 1 plus recall 3. Square root it. 1 over x times recall 1. So my test statistic, my t-stat is negative 2.117. That is my test statistic. Negative 2.117. Keep only 3 decimals because we are looking for a t-value. Now what is my decision? Reject it, because this guy is less than 1.993. Then there is even evidence to conclude my mu Boston minus mu Buffalo is less than 0. So this is my decision. There is even evidence to conclude mu Boston minus mu Buffalo is less than 0. So what we are doing here, while we are trying to compare this to sample space, okay? While we are trying to compare the data that we collect from 59 residents in Buffalo and 32 residents in Boston. The reason why we're doing this is we want to use the sample data to predict how these 2 cities, how these 2 host cities, how about this 2 population, right, works. So in this case, by doing this hypothesis casting, I can say the population average in Boston is no less than the population average in Buffalo. Does it make sense? Right? We're trying to use the samples to predict how these populations go. What is my p-value? What is my p-value? The p-value is the probability starting from your test statistic all the way to the direction of your tail. This is my test statistic. And what is the direction of the tail? I have a lower tail path. So I am looking for the probability from negative 2.117 all the way to the left. All the way to the left. Now I go to the t-table again. Row 74. Where is 2.117? 2.117 is in between 1.993 and 2.378. So the p-value for 2.117, the p-value is greater than or equal to 0.01, but less than or equal to 0.025. 2.117 is in between 1.993 and 2.379 in row 74. That is how we locate this number, 2.117. And we go up to find the probability that this guy is in between. So that gives me 0.01 to 0.025. Well, should I do a 1 minus?
No.
No. I don't need to do that. Why?
That's not a 2-2.
Because based on my graph, this is very, very small area, right? So we don't need to do 1 minus. What is the 80% confidence interval in terms of Boston minus Buffalo? Do they switch the order? No. Okay. We have the same order. We have 80% confidence interval. We have 80%. So the first step is always draw a P. I have 80% in the middle, which means I have 10% in each tail. Since we're using the t-table, then the area for my upper tail matters, right? I don't go to the left. This time I go to the right because I'm using t-table. So what is my alpha? 0.1, right? My alpha is 0.1. All right. So what is what is the formula for the confidence interval? X bar Boston for Boston minus X bar for Buffalo minus the t value, right? What is the part under the square root?
S1 squared over N1.
Plus S2 squared over N2, right? So my X bar for Boston is given, X bar for Buffalo is given. What is my T? What is my T? My DF is 74, right? My DF is 74. However, in this case, my alpha is not 0.025. My alpha is 0.1. So I go to the row 74. What is the t value with a probability of 0.1? That is 1.293. Row 74. 0.1 give you 1.294. Now you have everything.
93. 93. Yeah.
Well, here's the thing. Here's the question that students keep asking. Can I use the same t-credit that I have already found in step 2? Use that t-credit to find my confidence interval? Can I do that? No, because this t-credit is with respect to this alpha, right? My new alpha is 0.1. So I cannot use my t-credit, right? In the formula of confidence interval, I have to find the new t-value, which is 1.294 in this case. Yep. Row 74. That's my DF. No, 1.293. 293. The intersection between row 74 and my first column. And that gives me 1.293. That's my T value. All right. Is there any questions for